Welcome to Networks Professionals.
You ever stop and think about how your phone just knows your face? Or how a self-driving car can see a stop sign? It feels like straight up magic. Well, it's not magic. It's an incredible field of AI called computer vision. And today, we're going to pull back the curtain and see exactly how machines are learning to see our world. Seriously, how does your phone unlock with your face? And how on earth does a car see a pedestrian? I mean, we do it without thinking, but for a machine, that's a whole different ballgame. A machine just sees numbers, right? So how do we teach it to understand the incredibly rich visual world that we totally take for granted? That's the puzzle we're going to solve today. All right, so first things first, we've got to get our heads around the fundamentals. Because how we see the world and how a computer sees it, they are worlds apart. We're going to go on a little journey here, from a chaotic jumble of pixels all the way to real, actual perception. So what exactly is computer vision? Well, you can think of it as this really ambitious quest. We're trying to teach computers to understand images and videos just like we do. The end goal? Giving machines something like human sight. And that could mean anything from spotting your cat in a photo all the way to helping a doctor find a tiny tumor on an MRI. It's a huge deal. And this is where it gets kind of wild. You know, when you look at a picture of a park, you see the whole scene, right? You see the trees, the grass, the people. You get the vibe of it instantly. A computer? Nope. It sees a massive grid of numbers, literally like a giant spreadsheet where every single cell is a number that represents the color of one tiny pixel. The computer's entire job is to somehow find patterns in that massive wall of numbers to figure out, hey, is that a tree? Is that a person? Okay, so how in the world does a machine make that leap? How does it go from that giant spreadsheet of numbers to actually recognizing, say, a car? Well, it's not just one magic step. It's actually a really clever multi-stage process. Let's break down exactly how it works. It all starts with step one, which is super simple: image acquisition. You just take a picture. Easy enough. Then comes step two, pre-processing. This is like cleaning up the photo, removing any blurriness or digital noise so the AI has a clear image to work with. Now, step three, feature extraction. This is where the real magic starts. The AI isn't looking for a dog or a cat just yet. It's hunting for the basic building blocks, simple things like edges, corners, and different colored shapes. Finally, in step four, model analysis. A powerful neural network takes all those little pieces and starts to put the puzzle together. It learns to connect the dots and say, hey, all these edges and colors, that looks like a cat. It's this amazing process going from raw data to actual insight. So once a computer can actually make sense of an image, it opens up a whole world of possibilities. It can do all sorts of amazing things. It's kind of like having a toolbox, but instead of hammers and screwdrivers, you have these specialized vision tools, each one perfect for a different job. And this is what's so cool, the sheer variety of these tools. We're going to dive into a few of them. We'll see how AI can not only find an object, but pinpoint its exact location. How it can literally read text right off a sign. How it can pick one specific face out of a crowd of millions. And then, the really mind-bending one, how it can now generate completely new images that have never existed before. All right, first tool in the box, object detection. Now, this isn't just about the AI saying, yep, there's a car in this picture. It's way more specific. It's about knowing exactly where that car is, and it does that by drawing what's called a bounding box right around it. And you can imagine why this is so critical for something like a self-driving car, right? It needs to know the precise location of every other car, pedestrian, and cyclist on the road. And one of the most famous models for this has a great name, YOLO. It stands for You Only Look Once, and the name tells you everything you need to know. See, older models were kind of slow. They had to scan an image over and over to find everything. YOLO was a game changer because it figured out how to do it all in one single pass. It just looks once, finds everything, and boom, it's done. That makes it incredibly fast, which is perfect for real-time video. But sometimes a simple box just isn't detailed enough. And that's where our next tool, image segmentation, comes in. This is on a whole other level. Instead of a box, segmentation colors in every single pixel that belongs to an object. And there are two main types here. You've got semantic segmentation, which is great at saying, okay, all these pixels are road, all these pixels are sky, and all these pixels are car. But then there's instance segmentation, which is even more precise. It doesn't just see car, it sees car number 1, car number 2, and car number 3, all as separate things. That's absolutely vital for navigating really complex scenes. Okay, next up is a tool you've probably used without even realizing it: optical character recognition, or OCR. You ever take a picture of a document with your phone and it magically becomes editable text? That's OCR. The AI has been trained to recognize the shapes of all the letters and numbers, so it can literally read the text right out of the image for you. It's super handy. And then, of course, we have facial recognition. This one is a really specialized task, and it's all about precision. The AI isn't just going, oh, that's a face. No, it's analyzing the unique geometry of your face. It's measuring the distance between your eyes, the shape of your nose, the curve of your jaw. All these little points create a unique digital map. It's basically a fingerprint for your face. And yeah, that's exactly what's happening every time your phone unlocks with just a look. So, we've got this amazing toolbox. But this isn't just theory, right? Where is all this stuff actually showing up in the real world? Let's take a look at how this technology is already changing our lives right now. I mean, the applications are everywhere, and they're game changers. Self-driving cars completely depend on it to see the world around them. In medicine, it's becoming this incredible co-pilot for doctors, helping them analyze X-rays and MRIs to find things a human eye might overlook. In retail, cameras can now automatically track inventory on shelves. In robotics, it's what gives a robot the eyes it needs to navigate a warehouse or assemble a delicate piece of electronics. It's everywhere. But hold on, because this is where things take a turn into science fiction. Up to now, we've been talking about how computers see our world. But what if they could create new worlds? That's what's happening right now. This is the world of image generation. You've probably heard of models like DALL-E or Midjourney. The idea is wild. You just type in a text description, anything you can imagine, like a photorealistic painting of a fox in a library, and the AI creates a brand new, totally original image from scratch. It's not just interpreting reality anymore, it's imagining. So how on earth does it do that? How does an AI imagine? Well, the secret sauce behind a lot of these top-tier models is something called a diffusion model. And the core idea is actually pretty brilliant, if a little backward. Imagine you have a perfect picture of a dog. Now, you start adding a tiny bit of static, or noise, to it, then a little more, and more, until the original picture is completely gone, and it's just a screen of static. The AI is trained to do the opposite. It learns, step by painstaking step, how to remove the noise to get back to that perfect picture of the dog. Once it gets really, really good at that, you can just give it a screen full of random noise and tell it, find a dog in there, and it will. So think about that journey for a second. We went from teaching a computer to recognize a cat in a photo to teaching it how to create a picture of a cat that has never existed. That's a huge leap. And it leaves us with this one big, fascinating question. If computers can now see our world and create entirely new ones, what on earth will they
Thanks for watching.